Use A, airport A is 30. D, the percentage of travelers that use airport is 45, 30, and 25. Given that a traveler has a weapon in his or her possession, the probability of being caught is 0.7, 0.9, and 0.84 for each airport respectively. So I like to use a tree diagram. You don't have to, but I like to. So you have 3 airports. It's either you travel from airport A, or you travel from airport B, or you travel from airport C. 3 airport, you choose which one you want to travel with. Airport A, airport B, airport C. Most passengers tend to go with airport A because 0.45, that's 45%. 30% go with airport B, and 25% go with airport C. All right. Now, if you go with airport A, it says chances of you getting caught at airport A is 0.7. So the chance of you going to airport A and getting caught, so I'm going to use D for getting caught. Chances of you getting caught, let me write D here, and this is D prime mean not caught. So the chances of you getting caught at airport A with a weapon is 0.7. So the chance of you not getting caught at airport A is 0.3. Then the chance of you getting caught at airport B with a weapon is 0.9. So pretty much they're telling you, once you have a weapon, 90% of the time you get caught. So if you have a weapon, don't go to airport B because you're going to get caught 90% of the time. And that means you're getting banned. You can't go, you can't leave the country no more. Airport C, there's an 85% chance you get caught. So pretty much the best airport where you can get away with is airport A, and 70% of people get caught. So more than likely you have to really skill to get away. I think I could get away. I'm just kidding. But that's why I figure that is why so much people go to airport A, because it have the lowest probability of getting caught with a weapon. All right, so this is a tree diagram. Okay, why did I create a tree diagram? I have no idea, but I just like to have a tree diagram. It helped me with calculations sometimes. It says, what is the probability that a traveler using an airport in country X is caught with a weapon? So they want the probability of you getting caught with a weapon. Now I see why I use the tree diagram. The probability of you being caught with the weapon is equal to the probability of you getting caught at airport A. The probability of you getting caught at airport A is going to be 0.45 times 0.7. It's going to be equal to the probability of A times the probability of you getting caught at airport A. So it's 0.45 times 0.7 plus the probability of you using airport B and getting caught at B, which is 0.3 times 0.9 plus the probability of you getting caught at C, given that you went to airport C, which is 0.25 times 0.85. That's the probability of you getting caught. So when you work that out, that will give you the probability of you getting caught with the weapon, which is 0.45 times 0.7 plus 0.3 times 0.9 plus 0.25 times 0.85. That's 0.795. There's a high probability of you getting caught, 0.975. Now let's say it didn't create a tree diagram. The alternate method you could do it is using what's known as total law of probability, right? Because up here, so what they were giving you is they give you the probability of A, the probability of going to airport A, they told us was 0.45. They told us the probability of going to airport B, and the probability of going to airport B, they told us that was 0.3. And then the probability of going to airport C, they told us that is 0.25. All right. Now, over here, so now is a conditional probability. The probability of you getting caught, given that you were at airport A. So given that you went to airport A, the probability of you getting caught is 0.7. Then the probability of you getting caught, given that you went to airport B, was 0.9. The tree diagram is very good, but also if you know the formulas, it's very good. It's very good either way. And then the probability of you getting caught, given that you went to airport C, is equal to 0.85. All right. And so the OR method, this is the OR method. The OR method would be to do this. You could say that the probability of getting caught D using total laws of probability is equal to the probability of A is equal to the probability of A, the probability of D given A times the probability of A plus the probability of D given B, D given B times the probability of B plus the probability of D given C, probability of D given C times the probability of C. This is total law of probability, all right, which we should know very easy. All right, this is just total law of probability. And this is really just the probability of A intersect D. This is the probability of B intersect D. And this is just the probability of C intersect D. All right. So you could use the formula and you're going to get the same 0.7975. All right. That's the OR method. Let's look at the final part now. It says, on a particular day, a traveler was caught carrying a weapon at airport in country X. What is the probability that the traveler used airport C? On a particular day, a traveler was caught carrying a weapon. So they're saying, given that he was caught on a particular day, given that he was caught and he was coming from airport C, all right? So it says, given that he was caught, so this is what they're asking. Let's write it down now. So part 2 of this question. Part 2 is saying, given that he was caught means given that he was caught, given is D, what is the probability he was caught at C? They're asking you for the probability of C given D. The probability of C given D is the probability of C intersect D over the probability of D, right? Now the probability of C given C intersect D is going to be equal to probability of C intersect D is right here. It's 0.25 times 0.85, 0.25 times 0.85, divided by the probability of D. The probability of D, which you just work out, is 0.7975. 0.7975. So you put all of this in a calculator and it tells you the probability that you get caught with a weapon, definitely at airport C. 0.75 times 0.85 divided by 0.7975 is 0.266. All right, that's the chance of you getting caught at airport C. Nice. That takes care of question 5. So now we have the final question to do, and then we'll finish. Final question. Question 6. Question 6. Let's go ahead.